should be good. Whoops, I don't want to expose Nikhil. Hold up. Where are my tabs? Okay, there we go. Let me make Jeff Hu a co-host so that this is not confusing. Okay. So essentially, you guys wanted to see the walkthrough for people are still coming in. Most of you guys wanted to see number 1. Okay, does anybody here want to see the bronze stuff? Because if you do, raise your hand so that I could put you in a breakout room. Anybody? Nobody? Okay, so everybody here for the silver still. Okay. So basically, for this problem, you basically have a line of cows, right? You have 5 cows, right? And they basically undergo 4 swaps, right? So what is the initial ordering of the cow? I'm just gonna write it here. It's 1, 2, 3, 4, 5. The second one is gonna be swap 1 and 3. You get 3, 2, 1, 4, 5. Then you get 2, 3, 1, 4, 5. Then you get what's next? 2. What is after? 2, 1, 3, 4, 5, and 2, 4, 3, 1, 5. Okay, so this is the first step, right? And basically, like, you repeat this infinitely, right? So essentially, like, you want to see where each number goes. So just looking at this, which places does 1 go to? Just in this 1.
2, 3,
1, 4, 2.
1, 4, 2. Wait, really? 1, no, 1, 3, 2, 4. Yeah,
Oh,
so
1,
1, 2,
yeah.
3, 4, all of them. Then what does 2 go to?
1, 2, 3, 4.
No, it doesn't. Wait, only in this, like, 1, like the first case swaps.
Oh, 1 and 2.
1 and 2, 3 goes through.
1, 2, 3.
1, 2, 3, 4 goes through. 2 and 4, and 5 goes through 5. Okay, so essentially, like, this is after 1, right? And it keeps going infinitely. So let's just look at 1. So 1 goes 1, 2, 3, 4. Oh, let's look at 5 because well, which is an interesting one? Yeah, I think 1 is probably the most interesting. Or no, let's say 2. So 2, it starts over here and then it goes to 1, right? So now it starts the next cycle when you do the case swaps again. It starts at 2, 4, 3, 1, 5. So looking at this, how do we immediately know what 2 is going to go through in the next session, in the next case swap?
Oh, you give it index 1 and then do the...
Well, basically, we
Just
know
give
that
it
it's
the
going to go
values
through
now.
everything that 1 went through in the first time, right? Basically. So we could essentially just merge this in here, and now 2 is 1, 2, 3, 4, right? And then let's look at 2 again. So 2 now ends up where? After the second K.
4.
Position 4.
Yeah, so now we know, now looking at this again, how do we immediately know if it starts in the 4th place, which position is this going to go to?
2 and 4.
You go to the 4th one. 2 and
Yeah, you look at 4, you see 2 and 4, you merge it in here, but it's already there, so you're done, right? But essentially, what we saw there is that we basically went through the cycle, right? We went 2 to 1. Well, we went 2, and we saw it originally goes 2, 1, right? Then we look at 1, we saw that that goes 1, 2, 3, 4, so we add it into the 2. And then we know that 2 goes to 4, and then we basically look at what 4 went through, and we add that to here, and now you got your final answer for 2. It's the sum of 2, 1, and 4, right? So essentially, the key idea here is that, like, wait, why is Albert not getting admitted? But anyways, you basically know that 1, 2, and 4 go in a cycle, right? So 1 goes to 2, 2 goes to 4, 4 goes to 1, and then they're back to original position, right? You guys understand that? Like, 1, 2, and 4 cycle between each other until they return to their original position, right? So essentially, 1, 2, and 4 all go through the exact same, they all go through the exact same spot. So that's why in this case, 1, 2, and 4 all are four options, right? They all go through the same stuff. 3 ends up exactly where it started off, so it's not in a cycle with anyone else, so it has its own number, and then 5 is also in a cycle by itself. So essentially, if we just go through the algorithm, basically we could do this in what is it, O of like k time, basically. So let me just show you how to do it. So let's just say that group 1 is 1, 2, and 4, right? Group 2 is what would the second group be? So we're breaking it up into groups of people who cycle between each other. So what would the second group be? So 1, 2, and 4 are all together. Then what would the second one be?
1 and 3.
1 and 3? Why,
Or-
why 1?
Wait,
Why?
my bad.
3 just goes to itself. So what is the group?
Oh, just 3.
Yeah. And then what's the third group?
5.
5. Okay, so let's just go through it. Our first swap, which are the only two things that are moving? Which are the only two things that move in the first swap? Any ideas? Okay, the only two things that are moving in the first swap are 1 and 3, right? So we look, 1 is in group 1. Okay, so now 1 is moving to group 3, so all of the guys in group 1 will eventually hit 3, right? And we also know all the guys in group 1 will hit 3 eventually, right? Okay, then you look at the second swap, you're swapping 1 and 2 from these two, so only 3 and 2 are moving, right? Well, we also have to see that like 3 is moving to 1, so in 3 we add 1, okay. I mean, sorry, group 2, you add 1. 3 has nothing so far, right? And then in the second swap, 2 swaps with 3. So 3 is moving to the second position, so we know that group 2 now hits the second position, and we know that 2 now goes to the first position, so we know that the first group now hits 1, right? And then eventually you go through it, you go through all this and add to the corresponding group, and then you take the size of the set, and you eventually get like how many numbers each cycle goes through, right? So let's just code it up real quick. So what are we gonna call this? Moves. Moves is a good name. Okay. All right. So basically, what's the first step after we read in stuff? So what was our first step when we did the example?
To simulate the cave moves.
Yeah, to simulate the K moves. And what do we want to find out after we simulate the K moves?
The final position.
Yeah, we basically want to find the final position, and then what do we want to use the final position to do?
Find like the groups.
Yeah, we want to find the groups. That is what I was trying to get at. We want to find the groups that they're all in. So we'll just do this, okay? And then we'll have a PII array of swaps, right? Swap 1001. Okay. So now we just read these guys in. Bruh. And then, dang, why is typing so hard? Okay, so then we see in swap I dot first and swap I dot second. Okay, so how are we going to what's the problem here? Oops, okay, I guess we had to do swaps. Okay, so now we're basically gonna do all the swaps, right? Well, we could even do it here. So we'll keep track originally of position, right? So we'll have int position 1001. And what do we want to set the position to originally? What is the position of each thing originally?
1, 2, 3, 4, 5, all the way to 10.
Yeah, so essentially we want position I is equal to I. Okay. Okay, so now we gotta swap. What do we do? How do you swap stuff?
You just swap.
Yeah, exactly. Yeah, so essentially then you set position swap I dot second to equal position or sorry, dot first bro, is equal to this dot second. Okay, and then eventually what do we gotta do last? What do we gotta set to temp? Swap I dot second is equal to temp. Okay, so now essentially this is gonna simulate all of the swaps, and then if we want to print out at the end, what should we get when we print out position? Any ideas what we will get when we print out position? Whoops, 1 less than equal to n. Okay, so you basically get 2, 4, 3, 1, 5, which is basically your final position, right? So now what do we want to do with this final position, people? What do we want to do? We want to find the groups, right? So essentially, we'll have which group they're in, right? So int cycle is 1001. And then what do we want to set the cycles to originally, just to show that we don't have a cycle? I'm just going to say we're going to set it to -1, just to show that we haven't put it in a group yet. And then essentially, if it is in a group already, so if cycle I is not equal to -1, then we want to continue. But if it is not already in a group, then we got to put it in a group. So we should keep track of which group we're on right now. So it'll start at 0. Okay, so does anybody know how to do cycle kind of stuff? So basically, let's just say we start at 1, right? So cycle 1 is going to equal to the current cycle, right? Okay, then what do we got to do in order to find everybody in the cycle? Any ideas? Okay, so essentially the way you do it is you set car to position I, right? And then while, what do we want to do? How do we keep going through the cycle? So essentially we start at 1 and we see that the cycle is 2. So then where should we go next? So if we start here and it's the number is telling us 2. So where should we go?
You go
Go
to
to
2.
2.
Yeah, so then we go to 2, we see that there's a 4, then we go to 4, and then you see it's a 1, and then you go back to 1, and when do you stop?
When you go back to 1.
Yeah, so when car is equal to I, or while it's not equal to I, then you basically keep going and you set cycle I to equal car cycle, and then what do you set car to after you do that? Or sorry, cycle car. Car is equal to position car, basically. Okay. So essentially, if we print this out at the very end, I equals 0, I less than equal to n, I plus plus. We see out cycle I. 1. Okay. So what should the numbers be, do you guys think? That is not what they should be. Hold up. Oh, okay, over here you had to do car cycle plus plus. Okay. Okay, so see, we got 1, 2, and 4 are all in the same group. 3 and 5 are in separate groups. Okay, now what do we got to do once we have the groups? Any ideas? Any ideas?
Wait, hold up. How is 0, 0, 1, 0, 2 show that they're in the same group?
So all the ones that are 0s are in the same group, all the ones that are 1s are the same group, and all the ones that are 2. So this is basically saying what group each one is in. So
Okay,
1 is in group 0, yeah, so on and so forth. So now that we have the groups, what do you want to do?
You look at the stuff in the groups, you see what to go through.
Yeah.
And then
So what do you want to keep track for each group? What data structure will be good for keeping track of unique elements that each thing goes through? Starts with an S. What's good for keeping track of unique elements? Nobody knows, really? This is very important. I mean, okay, well, it is a set, okay? You gotta have sets. So essentially, what a set is gonna do is it won't let you have duplicates. It'll insert an O of log n time. It's a very fast way of keeping track of unique elements. So essentially, we'll have a set of ints for each group, right? So we'll say set int group, or we'll go through, what should we call it? Positions. No, I'll just call it P. Why not? That's a good name. Okay, so right here we're just gonna put, like, obviously 1, 2, and 4 are all gonna go through each other, right? So like we can just immediately push them over here to the set. So we're gonna say P of I dot insert I, and then in here we're just gonna do P of car dot, or sorry, P of car cycle is the group, and then P of car cycle dot insert car. Okay, so now so the sets are going to be 1, 2, 4, 3, and 5, right? So those are the 3 sets. Now we basically want to go through each swap, right? So we go through the swaps. Okay, so now how do we do this? How do we, like, okay, so obviously we want to restart our position, so we want to go through the swaps one by one, right? Okay, so what is the strategy? We are looking at swap I, right? So what do we add to each set? Okay, so let's say we're swapping 1 and 3. What sets change?
the 1 instead of 2.
Yeah, right, because 3 is in group 2 and 1 is in group 1. So what gets added to group 1?
3,
3 gets added to group 1, and what gets added to group 2? I mean, yeah, group 2.
1.
Exactly, right? So essentially the group of the first guy gets added, like you add in the position it's moving to and the reverse, right? So we'll do P of the group of the first guy, right? So of swaps I dot first, right? That is the group of the first guy dot insert. We want to do swaps I dot second, right? That's where it's going to. And then we just do the opposite for the other one. Okay. And then at the very end, and then we also want to just do our like actual swap. Okay. And then at the very end, let's just print it out to see what we got. Less than or equal to n I plus plus. And then we'll just do for like I don't know, let's see. For j int j in our set, so we'll do in what pi, we'll see out what I j and then end L. Okay. Okay, so you can see that well that seems a bit wrong. Hold up. Should be 0 to n. Okay. Okay, so you can see that it worked, right? So essentially everybody in group 0 is going to 4 things, right? Everybody in group 2, which is a 3, is going to 3 things, right? And everybody in the group 2 is going to 1 thing, right? The only 2 is this last guy. So now how do we finish off a problem? We basically have everything we need. What do we print out? What are these? So this is all stored in the set, right? 1, 2, 3, 4 is in the set 0. So how do we get how many things are in group 0? Or what do we print out for like the first one? What represents how many things it could get to? The set represents what it could get to, so then what part of the set represents how many things it could get to? Anybody?
Second element. Or like the length.
Yeah, the length. Yeah, there we go. That's what I was getting at. So essentially for each one, we want to print out the length of P dot of the group it's in, right? So P of cycle I dot size. And I think this should work. Hey, very good. Okay, so let's try submitting it just so we could get the epic green. Okay. Whoops. Don't look at my password. It's okay, let's see. I may or may not have already submitted it, but let's try it again. Okay, let's see if it works. No, it doesn't. Bro, what did I do wrong? God dang it. Did I do some sketchy stuff somewhere? Oh, did I make this too small? Wait, what? What did I do? Hold up. Okay, wait, let me just hold up. Let me debug this real quick. I have decode over here, so it should be good. Oh, I see. Okay, well, let us just look at this and we can test this. Okay, yeah, so basically you can see the decode and yeah, basically that should be fine. Let's submit this. Bro, why did USACO make you rename these guys? Okay, main 2. All right, okay. So now we can talk about number 2. Bruh, what? God dang it, this is so sad. Wait, what? Seriously, you're not allowed to do that? You know what?
Hey, bro, you added a space.
Wait, I took out the space. I thought, okay, let's say main. All right. Okay, there we go. This should work. All right, very nice. Okay, I just had to get that. Okay, so now problem number 2. I'm not gonna live solve for you guys, but I'll just explain how it works. So, what is the brute force solution that you guys would come up with for problem 2? So you have A, B, B, A, B, C, B.
You just create individual lists based on each of the separations, and then run like a stroke counter function on it.
Okay, yeah. So, what's the efficient way to do stroke counting? Let's just say we want to find out like the strokes for A. So we start at the beginning. We go here. When does the stroke end? How do we know a stroke has to end? Any ideas?
When you find a stroke that's lighter than it, or when you reach the end.
Yeah, exactly, right? So for A, the only reason it ends here is because there's no more A's to the right of it. For B, you know this has to end here because there's a lighter color, right? Once it hits an A, you know it has to be like end there, right? And then it's a new one starts here, right? So essentially it's pretty easy to find these strokes, right? So once you have the strokes, right, let's just say A has like, what's the stroke for A? What index to what index?
It's too small to count.
Like 1 to 6, I think. Yeah. Wait. Oh no, 1 to 5. Did I do extra? Yeah, I did extra here. 1 to 5 should be right. Okay, then what about B? What are the 2 strokes?
2, 3, and then 4, 6.
4 to
Wait, my bad.
6 to 8. Yeah.
No, I'm bad. 6 to 8.
Yeah, and then C is just what?
7.
Okay. So now essentially, what's the brute force solution for answering a query when you just like cut out a piece of it? What's the brute force? You just like recalculate strokes for both sides, right? But the problem with that is that you're doing a lot of extra work, right? Because essentially everything that's not impacted by the gap remains exactly the same, and you already counted that. Like you're counting that every single time. So how could we use the the calculation we did without the gap to find the answer with the gap? Any ideas? Well, essentially, like, what are the 2 options, right? The gap could either do what? What could the gap do? Like, in terms of how could it change the number of strokes? What would the gap have to do in order to make the number of strokes increase? Any ideas? Nobody? Okay, well basically what I'm getting at is that in order to increase the number of strokes, you have to split an existing stroke into 2 parts, right? And in order to get rid of a stroke, what do you have to do? Does anybody know?
It is exactly on top of its full stroke.
Yeah, it fully covers any stroke, then that stroke is gone, right? You don't actually have to do that stroke. So there's basically 2 cases, and you gotta check whether it completely goes over a stroke or whether it doesn't go over a stroke. So why don't we just do 2 examples, right? Let's just say, like, let's just say we wanted to see whether like the index 77 broke up like a B stroke. How do we quickly find out whether it breaks up a B stroke? So without looping through all of the B strokes. Okay, well what are the constraints on the left and right bounds of the array? I mean of the thing, of the range. How do you know that it breaks something in 2? Like what inequalities do you have to write?
The left of your like break is wait, hold up, is smaller than the right of like the smallest stroke on the left of B,
Kind of.
and
Well,
then it's bigger than like the first
yeah,
index
yeah,
and the
exactly.
second
Yeah.
one.
So what I'm trying to get at is that your first is greater than the left, and your right is less than the right. Strictly less than the right, right? So if that's true, then you're basically done. So essentially, if you loop through all of it, it's too slow, right? Because you might have like n like B strokes, right? So that would be too slow. But we could do. Does anybody know how to find stuff in a sorted array? Nobody knows how to find stuff in a sorted array. That is very sad. Okay, well, basically you just binary search on the first one, right? So where does the 7 fit in against 2 and 6? Anybody? Where does 7 fit in 2 and 6? Like what index? So 2 is index 0, 6 is index 1, then what index would 7 fit in?
2,
Yeah, and then what about the ending points between 3 and 8?
1.
Yeah, so essentially the only way for this to be within a single set is if the index of this is 1 less than the index of that, right? That is the only way for it to fit within a single thing. Okay, so we know that. What happens if we did like 1, 9? Then where does the 1 fit in between 2 and 6? What index?
0,
Okay, then what about 9?
3, or 2.
2, right? So essentially we do 2 minus 0 and you get 2. 2 sets. It's between, 2 sets are in between it, right? So essentially how many does that add or subtract from our total?
Oh, you subtract 2.
Yeah, exactly, right? So essentially we were able to find in log n time how many to subtract and how many to add, right? So if there's q queries, you just do q times log n and that is your answer, right? And you basically go through each letter. Each letter could be treated independently. So I guess, well, does anybody have questions on this? Because the last one is super, super easy. I could literally go over it in 1 minute. Yeah. Okay, well, I know lunch is over now, so if you guys need to go, feel free to dip. But yeah, this one, all you had to notice is that it has to alternate, so you just like sum up rows that are alternating. Once you realize that it has to alternate, then it's pretty easy. Okay, if you have any questions, feel free to stay, but other than that, we are done for today.